Hi, everybody. Good morning. We're going to learn about our last topic for the year, and that is blood typing. So, you may or may not have learned about blood typing in the past, but this is the last thing that I have chosen to do. There's a lot of other things that we didn't do, so I apologize for those of you who are not going to take an anat and phys class in the future. Because you kind of missed out on some stuff, but that's just the way that the cookie crumbles this year. So in terms of blood typing, there's 8 different types of blood types in Americans, or I'm sorry, in human beings. There are actually other types too, but we're going to go through the 8 most common. And those are A, B, and O. And then there's positives and negatives for each one of those. And I'm going to teach you not only what the A and B means, but also what the positive and negative actually means. So when we talk about the percentage of Americans that have each, this is a little bit different maybe this year as opposed to last year. I just didn't update my numbers. So 40% of the population of Americans have A blood, 11% has B blood, 4% has AB blood, and 45% has O blood. So as you can see, O blood is the most common, and AB blood is the least common. And then when you look at the differences between positive and negative, you can tell right away by these percentages that a much fewer percentage of Americans are going to have negative blood than positive blood. And part of that has to do with the inheritance patterns of blood typing. So when we look at, for example, A blood, 32% of the people have A positive and 7% have A negative. And yes, I'm aware that these percentages don't necessarily add up, and that has to do with rounding. So don't worry about that. I'm not going to ask you what the percentages are. But like I, for example, have A negative blood. So does my daughter, and so does my husband. Actually, we all have A negative blood. So we are among the 7% of the American population that has A negative blood. So it's just kind of an introduction into blood typing. So when we look at blood typing and how we figure out, for example, what your blood type is, so how do we test for your blood type, and then how do we use that information when we're talking about things like transfusion. So if you need to get blood, why do we like O negative blood? So O negative is considered to be like a universal donor. And why is it a universal donor? So there are a couple types or a couple terms that you need to be familiar with. One is the term antigen, and an antigen is simply a protein that is on the surface of any cell. So if you remember, there are lots of different macromolecules that make up our body. So there's proteins, carbohydrates, lipids, and nucleic acids. And proteins, we've talked about proteins primarily in terms of them acting as an enzyme. But there are also proteins that serve as what we call marker proteins. So these are macromolecules that are on the surface of a cell. So they're embedded in the cell membrane, and they identify the cell to the body. So when we look at like blood typing, if you have A blood, that's because you have A antigens. So A antigens were just the first antigens to be discovered, and that's why they're called A antigens. There's not some weird meaning to the abbreviations. If you have AB blood, because you have A and B antigens, you are considered to have AB blood. So these are simply, like I said, proteins that sit on the surface of the cell that tell your body that that cell is supposed to be there. Then there are an additional term called an antibody. And antibodies are what are created in your blood plasma, so the liquid portion of your blood that fights against foreign particles. So if you look at, say you get COVID-19, right? They're doing antibody testing on people, not as much as they probably should, but there are people who have antibodies against COVID-19, and they are little proteins in the blood that attack the COVID-19 virus. Most of the time, in order to get an antibody, you must have already been in the presence of whatever that foreign particle is. So when we talk about immunity, for example, the only way you can become immune to something is if that something is already in your body and you create an immune response to it. And that immune response is those antibodies. What's nice about our immune system, which unfortunately we don't have time really to go into too much, is that we can remember we have cells that will like almost live forever, that will create antibodies. So if, say, you get COVID-19, your body will create antibodies to it. And then hopefully 10 years from now, if you get COVID-19 again, you'd be able to fight it. Or if you can't fully fight it, you already have some immunity to it. So maybe your second case is not as bad as your first. Let's hope that doesn't happen, but you know what I'm saying. So when we talk about antibodies, if you have an antibody, an A antibody, that is going to attach to an A antigen. So the antibodies are named for whatever protein on the surface of the cell that they're going to attack. And then there is this thing called an Rh factor, and it's called an Rh factor because it stands for rhesus. And the reason why this is not like Reese's Pieces, but this is after a rhesus monkey. So we first discovered this antigen in a rhesus monkey. So an Rh factor is another type of antigen that we find on red blood cells. And you either have it or you don't have it. So if you are Rh positive, right? So if you're A positive, your blood type is positive, that means you have the Rh factor. That's about 84% of Americans. If you are Rh negative, that means you don't have that protein. So I am A negative, which means I would have A antigens, but I would not have the Rh factor on the surface of my red blood cells. And the reason why we're talking about these is because the way that my body would react to B blood is different than the way that my body would react to A blood if I would ever get into an accident and need a blood transfusion. So I'm going to get off of here for a second, and then I'm going to do a lecture to explain more of this, and then we'll get more into the genetics of blood typing.